Hi, okay, what we're going to do, we're going to look at factoring out the greatest common factor, and we're just going to look at some exercises on page 340 in your text. So let's start with number 4. So we are on page 340, so we're on page 340, and we're going to be looking at number 4. Now, number 4 gives you 3 terms. It is 70x squared, so one of the terms is 70x squared. The other term is 84x, so we've got 84x. And the last term is 42x cubed. And what I'm going to show you, I'm going to show you a way that I go about finding the greatest common factor for both the numbers that are in the terms and for the variables that are in the term. So let's kind of take a look at this. So first of all, the first thing I do is I just line up my numbers. So I got 70, I got 84, and I got 42. Then the next thing I do is I just kind of draw an upside down division symbol, and I know that each of these numbers have the factor 7 in common. So I write 7 outside there. And then I go through and I kind of do division for each one. So 7 goes into 70 10 times, 7 goes into 84 12 times, and 7 goes into 42 6 times. So I come down to my second row of numbers and I have 10, 12, and 6. Well, I know that each of those numbers have a factor of 2 in common. So I do another division, put a 2 outside there, and 2 goes into 10 5 times, 2 goes into 12 6, 2 goes into 6 3 times. Now in this row I have a 5, 6, and a 3, and the only common factor that those three numbers have in common is just 1. So pretty much when I'm looking at my greatest common factor for my numbers, when I look at the greatest common factor for my numbers, my greatest common factor is actually going to be the product of these two numbers. And 7 times 2 is 14, so 14 is the greatest common factor just amongst my numbers. Now, when I want to find the greatest common factor, when I'm given variables that are raised to exponents, the greatest common factor is always going to be the variable with the lowest exponent. So here we have x squared, here we have x cubed, and here we have x. Well, that's just an implied x raised to the first power. So the exponent on that is just 1. And since 1, of course, is lower than 2 and 3, then my greatest common factor for my variable terms is just x. So for that particular problem, for number 4, the greatest common factor is 14x. Now let's go back and let's look at another one. Let's look at number, let's look at number 6. That's interesting. Number 6. So number 6 on page 340 has the 3 terms. So we've got 60 a squared b to the 5th, and we've got 140 a to the 9th b squared, and lastly we've got 40 a cubed b to the 6th. Okay, that's what we've got. Now, how would we find the greatest common factor for this set of numbers? Well, okay, we're going to start the same way that we started the other one, which is, I'm just going to draw upside down division symbol, and I'm going to write each of these numbers in here. So we've got 60, we've got 140, and we've got 40. Well, I know that each one of these have a factor of 20 in common. So I put 20 out there, and then I do my little divisions for each one. So 20 goes into 6 3 times, 20 into 140, that is 7, and 20 into 40, well, that's just 2. Well, I get down to this row of numbers here, and I'm left with 3, 7, and 2. Well, those only have a common factor of 1. So my greatest common factor for this set of numbers is going to be 20. So my greatest common factor for here is going to be 20. Now let's look at how I'm going to determine my greatest common factor for my AB terms. Well, here, let's look at the A's first. Here I have, and let's do this in maybe a different color. Let's do this in orange. So here I have A squared, I have A to the 9th, and I have A cubed. So my greatest common factor for my A terms is going to be the A term with the lowest exponent. Well, that's going to be A squared. So A squared. And now let's go ahead and let's look at my B terms. So I have here, let's do this in just another color. So I have B to the 5th, B squared, and B to the 6th. Well, my B term with the lowest exponent is my B squared, so I'm just going to write that here. So my greatest common factor for these three terms is going to be 20, A squared, B squared. Okay? So that's how you do that. Now, let's look at some more terms here. Okay? Let's go over here and let's look at some more problems in this section and see how we go about working those. So let's look at, for kicks, grins, and giggles, and let's just kind of really bump this up a whole lot of notches. Let's look at number 14. Yeah, let's look at number 14. Number 14, so let's do that. Number 14, still on page 340, number 14 is 44 x to the 8th power, y to the 6th power, and just z, of course, to the 1st power, minus 110 x to the 6th power, y to the 9th power, and z to the 2nd power. So again, I start the same way. I have 44 and I have 110. And one of the things that I notice is that both of those two numbers have a factor of 11 in common. So here I have 4 and here I have 10, because 11 goes into 44 4 times, 11 goes into 110 10 times. Now I come down here, I have a 4 and I have a 10. Well, I know that those have a factor of 2 in common. So here we are. So 4 can be divided into 2 times, and 10 can be divided into 2 5 times. So I get down to this Roman number, I have a 2 and a 5, and the only factor that both of these have in common is just 1. So my greatest common factor here, at least for my numbers, my greatest common factor for my numbers is going to be the product of 11 times 2, and that just gives you 22. So that's just for my numbers. Now, let's take a gander at my XYZ variables. So I have an x to the 8th power here and an x to the 6th power here. Well, between the two, which one of them has the lowest exponent? Well, it's going to be x to the 6th power. So x to the 6th power is going to be my greatest common factor for my x. Now let's go ahead and let's look at my y. So I've got y to the 6th here, and I have y to the 9th here. Well, which one of my two y factors have the lowest exponent? Well, that's y to the 6th. And for my z's, I have z to the 1st power and z to the 2nd power. Well, which one has the lowest exponent? Well, it's going to be my z to the 1st power. But we don't write z to the 1st power. We just write z. Okay? So my greatest common factor here is going to be 22 x to the 6th power, y to the 6th power, and z. So now that I have my greatest common factor, I can just go ahead and finish factoring this. So let's go ahead and let's see how this looks. So we started with, so our original problem was 44, x to the 8th, y to the 6th, z to the 1st power minus 110, x to the 6th, y to the 9th, z squared. Well, we found our greatest common factor. Our greatest common factor was this thing right here, the 22, x to the 6th, y to the 6th, z. So what I need to do to factor this is I need to find what factor I can multiply this by that will give me this. Well, I have 22. Well, to get 44, I need to multiply by 2. I have x to the 6th. I need x to the 8th. Well, I have 6 x's. I need 2 more for x squared to give me 8. I have 6 y's here, 6 y's there. So I don't really need to include my y's because I already have them. They're already here. And I have one z here and one z here, so I don't really need to include any of my z terms because they're already present as well. So then I go over, grab me another color, to my 110, x to the 6th, y to the 9th, z squared. Well, what factor do I need to multiply 22 by that will give me 110? Well, that's going to be 5. And then I have an x to the 6th here and x to the 6th there. So I've got what I need there. So I don't need to put any x terms, any x factors after that. So I have y to the 6th here, y to the 9th here. Well, how many y's do I need to make y to the 9th? Well, that's going to be 3 because 6 and 3 is 9. So y cubed. And then I have a z here, but I have z squared there. So I need, how many z's do I need? Because I'm going to need some z's in order to get a z squared here. So here I just need what? 1 z. So when I go to factor this, this actually factors into 22, x to the 6th, y to the 6th, z times 2x squared minus 5 y cubed z. And if we were to go ahead and use the distributive property to check this, which we should do, you all should always check your work. If I did 22x to the 6th, y to the 6th, z times 2x, 22 times 2, that's going to give me 44. X to the 6th times x squared, x to the 6th times x squared, and then we've got y to the 6th and z. Well, that's just going to give me 44. When you're multiplying two terms that have the same base, which in this case is x to the 6th x squared, you keep the base and you add the exponents. So 6 and 2 is 8. And we just have y to the 6th and z. Well, if we come up here, doesn't this match that? Yes, it does. So let's go ahead to the next one and check. So here, and let's do this in pink. So now we've got 22y to the x to the 6th, y to the 6th, z times 5y cubed z. So 5 times 22, well, that is 110. And we have x to the 6th. And we have y to the 6th times y cubed. And then we have z times z. Well, that's going to give us, we still have our 44 x to the 8th y to the 6th z minus 110. So we've got our x to the 6th. We have y to the 6th times y cubed. Well, when we're multiplying two terms with the same base, we keep the base, add the exponents. Same here. We have z times z. We keep the base. We add the exponents, which in this case would be 1 plus 1 equals 2. And if we compare what we have here with there, they both match. So we know that when we factor them, we did a good thing. Now, what I want to kind of touch on here, because I went through it, but I didn't really touch on it very good. Let's go back and let's look at when we went ahead and factored this. So I told you, I said, well, we've got, let me grab this color. We've got 22 x to the 6th, y to the 6th, z. But let's look at this from a different angle, just in case you didn't follow the angle that I came from. So let's look at this here. I have 44 x to the 8th, y to the 6th, z. So I have y to the 6th here. I'm sorry, I have x to the 6th. I keep misspeaking. I'm sorry. I have x to the 6th here, x to the 8th here. So I'm going to need two more x's to make my x to the 8th. I already have a y6 here. I have a y6 here. So I don't need a y6. So this becomes 1. I have a z here. And I already have a z here. So this becomes 1. And I did not put my 2 in front of here. Minus, and let's look at this again. We've got 22. So I need 5 here to make my 110. I have x to the 6th here, x to the 6th there. So that's going to be times 1 because I don't need to multiply it in. It's already there. And then I have y to the 6th, y to the 9th. Well, I'm going to need 3 y's to make 9. And I have a z here and a z squared here. Well, I'm going to need to multiply in an extra z to make my z squared. So I have 22 x to the 6th, y to the 6th, z times 2x squared times 1 times 1. Well, that's just 2x squared minus 5 times 1, that's 5, times y cubed times z. So that's another way of looking at it. So I hope that this helps most of you as you are going through this section, and I'll talk to all of you guys later. Bye-bye.